Hello everyone, this is Nitya Priya. Even today we are going to see the evolution of OS. In the way of seeing evolution of OS, we are going to see the various steps that the current day operating system has come. Then what are the stages it has come across, and those things we are going to see in evolution of OS. And these are the contents of our presentation. As the first step, we see the serial processing operating system. And the second one, we see batch processing. Next, we see multiprogramming OS. Then we see multitasking OS or multi-time sharing OS. Number 5, we see parallel system. Number 6, it is distributed system. Right. So this is the picture which says best about the different stages or the different types of the operating system. In early days we had serial processing, then we had batch processing, then it has been improved to multi-programming OS, then we see time sharing OS, then at last we see parallel system, then we see distributed system. Right, and this is the first stage of an operating system. In early operating systems, like in the days of 1940 till the middle of 1950, the programmer interacted directly with the computer hardware. We know pretty well, OS only gelled the computer user and the computer hardware. But in the early days, there were no OS. The the user just interacted directly with the computer hardware, and the machine without the OS was named after bare machine. Bare machine is a system or a computer system without operating systems. Every computer system is programmed in its own machine language. When the user submits a job, he used to submit the job using a device or a secondary storage device called punch card tapes. With the help of the language translator, he got translated the program which has been submitted and got it done by the computer. There are two concepts involved in serial processing. The first one is scheduling. Scheduling is actually when a job is about to use a computer system, the job has to reserve the time for using the computer system. So that time, getting the time or the reserving the machine is called as scheduling. The task of reserving the computer machine is called as scheduling. So they used a sheet called sign-up sheet to reserve the machine time, right? The user will sign up for the reserved time, and the whole time he has to use. And there will be, there is a problem in this, that is, if the user, for example, if the user got 1 hour time of the machine, and if the job got done within 45 minutes, the remaining 15 minutes will be a waste, or the computer will be idle. On the other case, if the job takes more than 1 hour, that is, if the job's running hour is lapsing, then there is no way of executing the job successfully because the time is already over. So that is a problem in serial processing, and this mode of operation is termed as serial processing, which reflects the fact the users of the computer can use the computer system one by one. So this is called serial processing. And the next concept is setup time. Setup time is how long or in what ways a single program will be using the computer system. A single program the single program needs to do loading, compile and source program in memory, saving the compiled program, which is object code, loading and linking together the object program and its corresponding common functions. So these are the steps involved in a single program running. So while executing a single program, that single program needs to do all these things in serial processing. If there is an error occur in any of this step, the user has to go to the beginning of the setup sequence, then he has to start from the beginning. So this is what happened in serial processing. If the system is not having any error, then it is over. The process will be successful. If there is an error, the entire system will collapse. So that is a major drawback of serial processing. So keeping up all these disadvantages of serial processing, we came out with the next type of operating system called simple batch processing. In other words, we can call batch processing. Batch is group of jobs. In early computers, they were very expensive because a single job cannot utilize the entire processor for a particular point of time. So what they thought was, if they use the computer processor for a couple of jobs or for a set of jobs, it could be easy for the utilization of the computer software and the computer hardware also. So keeping this in mind, they came up with this type of processing like batch processing. So the wasted time due to scheduling and setup time in serial processing was managed in batch processing. Actually, batch processing is a group of jobs with similar needs will be called as a batch, and this job will be allocated to the computer system with the help of the operator. So the operator will sequence the job. It will just make the job as a batch. The central idea behind the simple batch processing scheme is the use of a piece of software called monitor. So the user here also in batch processing, the user has no longer direct access to the processor. Instead, the user submits a job on such any of the secondary device called cards, tapes, etc. With the help of the computer operator. I said no. So the computer operator only batches the jobs together sequentially and places the entire batch on any input device whichever is available. So this input device will batched by the operator, will be just put on the input device, which will be used by the monitor. So each program is constructed to branch back to the monitor when it completes the processing. So this is called batch processing, and this is the scenario of batch processing. See, on the monitor for a single batch, interprocessing, device driving, job sequencing, interpretation, everything is loaded, and the single monitor will just portray these things of a single job. Then in the next slab we see the user program area. So there the programming will be done, and the other tasks other than the programming will be done on the monitor. So the point which is dividing these two compartments is called as boundary. Right, here we see the third type of operating system, which is multiprogramming OS. Multiprogramming OS is multiple programs running on a single operating system. Right. So these are the types of multiprogramming operating systems. Multitasking, whereas multiple tasks being carried out by a single operating system. Then multi-user, multiple users using a single operating system. Then multiprocessing, multiple processors being executed on different processors which are sitting under a single OS. So these are the types of multiprogramming OS. Right, and this is number 4, which is time sharing operating system. Time sharing is every process will be given a particular amount of time. So within that time, the process has to be over. So the operating system will be automatically switching on to the next process. So that is called time sharing OS. So each task is given some time to execute so that all the tasks would work smoothly. So each user gets the time of CPU as they are using a single system. Every system is known as, so this type of a system is known as multitasking system. The time which is allotted to each and every task is known as quantum. So when the quantum is over, automatically, as I said before, the OS switches over to the next task. So this is what happening in time sharing OS, and this is the scenario of time sharing OS. See, on the left we see many types of processes like Word. We are running a Word document, and we are also importing something. We are doing some task on our email. Then we have opened a browser also. So all these things are running on a single operating system which is on the center of the diagram. So this will be processed by the processor, which is CPU. Right. So this is the fifth type of operating system, which is called parallel processing. Parallel processing operating system. Actually, parallel processing is a single task or a single process is being divided or broken into different subtasks, and all these subtasks will be run by the single operating system. So many processes will be running, or the many tasks will be running on a single OS. This is called parallel processing. So parallel processing breaks the task actually. Okay. So like this, the single process will take very less time for executing. See, this is the scenario. P is the process. One scenario of parallel processing. P is the process which takes actually 5 minutes for processing it, and this P will be divided into 5 subtasks, namely P1, P2, P3, P4 and P5. So every process, every subtask from P1 to P5 will be allocated to different processors. So here they are processor 1 till processor 5. So when all the processors run the different subtasks P1 to P5 allotted to itself, it will take only 1/5 of the time. See, each and every subtask will take only 1 minute of time, and everything will be executed simultaneously. So totally for the process which takes 5 minutes, when it is carried upon on a parallel processing, it will take only 1 minute of time. So that is the biggest advantage of parallel processing. And so this is the slide which says elaborately about parallel processing. All the processes in the parallel processing environment should run on the same operating system. This is the first point. And the processors are tightly coupled. They are running on a single operating system. This means that tightly coupling. Then the processors in the system share the same terminal. Only the processors are different, but they share a single terminal. There is only one system here, right? And the last type of operating system is distributed operating system. Distributed system is currently being used. Distributed operating system is various autonomous systems running in a single environment is called as the distributed system, and every system will be having its own input output device, its own CPU, its own operating system, everything. So everything is a single, every unit is a single isolated computer device. So that is called as loosely coupled system. When they run on a single OS, it is tightly coupled. They don't share a single OS here in distributed operating system. Each and every system has its own operating system. So that is called loosely coupling. So distributed OS scenario is this. See, there is an operating system in the middle. There is a terminal around the operating system. On every terminal there is a CPU, there is input output device, there is a primary memory. So everything is there, and the single operating system is using all the isolated terminals. So this is called distributed OS. And these are the advantages of distributed OS. The failure of one system, one single terminal will not affect the entire network because they are independent. Everything has a processor in its own, everything has a device, IO device in its own, everything has terminal in its own. So failure of one will not affect the entire system. And the computation is, of course, it is highly fast and durable because they are loosely coupled, and scalability becomes so easy. Scalability, removal or adding a system into the network, right? So adding or removing any number of systems into the entire system is very easy. That is what we mean as scalability. Then the major benefit of working with these types of distributed OS is the user's files or software are always accessible because they are connected within the network, the remote access is enabled. That is, one monitor or one system can always get a file or a software from another system. So that is the major advantage of distributed operating system. And that's all about now. So see you in the next class. Thanks for watching.